Thank you. Good morning. The IoT is dead. Long live the things. Now, there's more hype than ever. There's more focus than ever on connecting all the unconnected parts of our world. And where the promises or hype of AI have reached a fever pitch, unlock the next era of machine intelligence. The supply side of the market certainly seems to agree, where the number of IoT startups has grown from around 1,205 in 2021 to over 3,300 today, according to IoT Analytics. And yet, for 20 years, we've saddled developers and product builders with a complex and unrealistic set of requirements and constraints when building connected products. Engineers and builders are locked into radio access technologies, ever at the mercy of network sunsets, scrambling to maintain systems insecurely reachable from the internet, and building systems that either do not scale or cannot scale economically. The enemy of connected products that are secure, reliable, economical, and can scale is DIY approaches driven by do-everything IoT platforms. A piecemeal chip-down design that uses obscure industry-specific protocols to connect an off-the-shelf modem to a custom-built or bespoke or packaged IoT platform. But the modem is a commodity, and IoT platforms are dead. We'll never connect everything that can and should be connected if we insist on doing more of the same over and over and over again. There is a better way, and we can get there by embracing harmonization of wireless technologies and interoperability across RATs and physical device services through API-driven approaches. We can get there by taking a principled approach, learning from the past, taking what's working for us and discarding what isn't. And today I want to introduce you to a methodology for building the next generation of connected products, the next generation of managed intelligent edge devices. We call it the 12-factor thing, and it represents a set of first principles for bringing physical products online. These are things that many of us at Blues have learned over a decade of working in this space, and what we learned building Blues and our products in response to many of the challenges and complexities that we've observed in the IoT. I want to share these principles with you all in the hope that it starts a conversation and gets us one step closer to connecting everything that can and should be connected. And by the way, everything that I'm going to share today is also available at 12factor.io, so you can visit that site later because we've got a lot to go through in a short amount of time, so buckle up and let's get started. First, let's start with edge devices. Now, a 12-factor thing, an edge device, is an embedded network device, but it is not an internet-connected device. Connected devices should not be designed as devices that are always connected and reachable from the internet. They should not expose themselves as sockets on the internet. Rather, they should connect securely over non-public networks and VPN tunnels to exactly two services, and only two services. One is a management service, a service that exists to deliver firmware updates to the device, to update the configuration of the device, monitor the device's health and connection, and to receive metadata about the device, its state, and behavior. And a solution service, which exists to receive application data from the device and then forward that data to authorized receivers, such as cloud app stores or archival services. These two services represent the only access that a connected product has to the outside world. This device is an embedded networked device. It is not an internet-connected device. Now let's talk about transport and the way that a 12-factor thing gets its data to those two cloud services. RATs like cellular, Wi-Fi, LoRa, and satellite have long required engineers to intimately understand and design for the features and constraints of each of these. These features and constraints impact the hardware and firmware design of a product, and so builders have typically locked them in and designed for one of these from the beginning and not had the flexibility to switch between them without a complete redesign. But a connected product should be RAT agnostic. It can and should be RAT agnostic and target a harmonized transport with a unified developer experience and allow transport-specific protocols to operate when necessary to do so. Now, a harmonized API does not mean that there's parity between all transports or that an API operates at the lowest common denominator. What it means is that the commonalities between all types of applications can operate across RATs, but that a device gives hints, or the firmware can give hints to the developer when it needs to operate in a different mode. So, for instance, an app communicating over satellite or LoRaWAN will want to ramp down its synchronization frequency and use more of a packet abstraction API. A webcam or a real-time voice endpoint will use a stream API and be mostly continuously connected to the internet. And most all apps simply use a data API to queue outgoing data and to retrieve incoming data from the cloud store. But all of the above can be made possible with a single module and a single API that abstracts these differences, so a single application can be built and deployed anywhere with a radio access technology that is appropriate to the location of deployment and the unique constraints of that location. Now, in an embedded device, events are the artifacts created by the operating behavior of the device, and state represents the condition of the device at a point in time. Now, a connected product should be connected from birth, and its events and state should always be synchronized and harmonized with its cloud service. Events should never be stored on a device permanently, merely cached until they're connected to the service, stored to the service, and purged. And state can be and should be stored on a device, but it should always be replicated to the device's management service, so there is a consistent view between what's going on the device itself and the cloud's concept of what's happening in the device. And not only that, but events and state can actually be stored and forwarded into downstream services like a time series database, like an analytics service, or even a data warehouse. But a 12-factor thing or a connected device should always have a concept of events on the device itself and the state that is used to manage the device from a cloud service. Now, this one might be a little bit controversial, but in reality, we believe that configuration, or that a device, should never be treated as a group of one, even from the first prototype. That a connected thing should instead use the fleet as the predominant organizational paradigm and the way that a connected product manages its life cycle, deployment location, and behavior of devices. So a fleet in this context is really nothing more than a non-exclusive grouping of devices that represent similar behaviors, and that's dictated by the scope of the fleet. So it could be an operational fleet, quarantine, repair, or decommissioned devices. But with fleets as a paradigm, device configuration should be managed from the cloud and multicast to fleets using collections of key value pairs called environment variables. Config is everything that is likely to change from one device to the next, and depending on its state. It could be logging frequency, it could be the behavior of a managed actuator, how you're sensing a device, etc. But by organizing around fleets, devices inherit the behavior, config, and intelligence of all the devices in that fleet. And as devices move between fleets, whether by design or by necessity, they benefit from a cloud-centric view of configuration and adapt their behaviors, that config is never stored locally on the device itself. Now let's talk about how a 12-factor thing can securely reach out to external services, because one of the realities of connected devices is that they sometimes do have to make real-time synchronous calls to modern web services. They may fetch data that's essential to the operation of a connected product, or they may actually need to send an alert for something that's mission critical. But the URLs, addresses, and API keys for these services should never be embedded in the firmware, and this is an important one. Instead, embedded firmware should refer to remote endpoints by name, for example, an energy service, which maps to a remote endpoint in the managed cloud service. That service then operates as a low latency, transparent proxy, which then takes the information or takes the request from the device, executes that call, whether it's a get or a put or an update or a delete, from the service, and then sends the result or sends the payload back down to the device itself. The device never has a direct connection to any of those cloud services directly. Now let's talk about how a 12-factor thing determines and shares its location. Now, device location is a complex topic for sure, and really depends on what RAT a device has access to. GPS is highly accurate, but it requires a clear view of the sky and is quite power hungry. Outside of GPS or GNSS, cellular devices have a tower location, and cellular, Wi-Fi, and LoRaWAN can all approximate location using multilateration techniques. But all of these approaches require coordination and with a cloud service and should not be the responsibility of the device itself. We believe that a connected product should utilize multiple RATs and utilize location services on multiple RATs, and then allow a cloud service to provide some view of the best location to service consumers. So this allows devices in the field to operate in a power-conscious way and defer calculation to the location service, which then can perform multiple levels of multilateration based on the number of location points or even the recency of the data that it has. So the end devices can rely on that location without having to take on the responsibility of doing the calculation. Now, time is a relatively easy and non-controversial one, but in reality, when we're dealing with devices that are sometimes offline, it's important that firmware keep track of time when disconnected from a cloud service, right? That time in some form should be appended to every reading, even if it's a sense of local time that is then reconciled with a cloud service when a connection is made. The reality is that there is no time series without time, and every embedded device, every connected device should make sure that its cloud services have an accurate view of time that can be replicated across its connections. Now, I doubt this next one will be too terribly controversial, but firmware. A device's firmware should be delivered by the cloud management service asynchronously and should be applied using a process that runs independent from the main application process. Now, this could be through a soft bootloader running on an isolated partition, or it could be an external module running an independent process. And in this latter case, for processors that have ROM-based bootloaders, you can actually build a connected product that has a physical connection between the module that's downloading firmware and that's connected to the management services and the strapping pins on the device, so that you can put the device into its bootloader mode and stream the binary in over a serial connection, apply that to the device. And this has the benefit of devices essentially being unbrickable. You can recover a device without actually having to physically get access to it. You can update the device with a diagnostic image, or in some cases, even update a part of the binary like a tiny ML model. Now, authentication is an important piece, obviously. Security in IoT devices is critical. And this is actually where we believe that the security model should be slightly different than what we treat it to be today. This is happening more and more, but a connected product should never store its keys, certs, or secrets in flash or removable media, and it should never rely on a cloud management service for key creation or rotation. A connected product should have a hardware security module or some secure enclave that is responsible for that connection and responsible for a secure connection between device and cloud. The device never delivers keys to the edge device and never relies on cloud-based key rotation. And even though the 12-factor thing is a client device, the security model really should be thought of as the inverse of how PC desktop security works. Right? The product, the service itself should be managed against spoofing of clients, and the device itself should be managed against cloud-based man-in-the-middle attacks. Now, logs provide visibility into the behavior, state, and environment of a device, but it's very critical that logs be treated as an output stream and literally just delivered to the cloud service without a lot of destination set by the device. The management service should decide where logs go without the end device actually dictating where that goes. Now, for the last couple of these, the second to last one I have is identity. And identity is basically just associating a connected product with the only identity that matters, which is the customer's product serial number. Devices have device IDs, modems have device IDs, but we should facilitate in management services the association between that device and the product serial number, because that's the only thing that matters. And doing so gives us the ability, when the product itself, when the connected thing is ephemeral and can be traded out, that connection to the ultimate device is preserved. Now, finally, testing. Because in the modern era, testing is not just a nice to have, but a must have for all forms of application and product development. And a 12-factor app embraces all forms of testing because of all of the other factors above. The cloud-based connection gives us the ability to actually put binaries onto devices to actually perform firmware update testing and integration testing and load testing as well against physical devices, and also to embrace emulation and simulation as an important part of the experience. Now, among all 12 of these things, I suspect that there are some that you find as obvious and some that are less so. And that's okay, because this is ultimately just a stake in the ground. We do believe this is a better way to build connected apps, but it doesn't necessarily have to be the only way. And this is truly just something that is a conversation. 13 years ago, a company by the name of Heroku and its CTO, Adam Wiggins, created something similar for SaaS devices called the 12-factor app. It's still available at 12factor.net. And what's interesting about this is that if you look today at all of these things listed in the 12-factor app, You might say, well, of course, that's how you do it. These are all common sense today. For example, but the reality is that there were a lot of those things that were not taken for granted back in that time, things that people did not do. There were a lot of apps that were not tracked in version control, that bundled their dependencies in source code, or which hard-coded their config. But the fact that we can look at these 12 things today as things we take for granted means that it worked. So let's do the same for the next 50 billion connected things. If you're interested in learning more, and I know I went through a lot of this very quickly today, so there's a whole lot more online at 12factor.io, or if you have any questions or there's ever anything that I or anyone at Blues could do to help you build your own connected products, you can email me at brandon@blues.com or come visit us in our booth. Thank you.